Hey guys, Mr. T here, just doing a video on the General Maths 2017 sample paper. So I'm going to do these solutions completely live, what's and all. If I need to do a number one, number two, I'll keep the video rolling so you know that this is how long it should take. No cheat sheet, hopefully my memory serves me well. Let's do it. Alright, so question one. Roberto wants to save 10 grand to buy his first car. He finds a saving account with an interest rate of 5.6% per annum, compounded monthly. Plans to deposit $200 per month into the account. So I'm trying to show you that you should try to highlight all the relevant information. Show that Roberto would have more than 2,400. Would have more than 2,400. So we're finding FV. So N is going to be 1 year times by 12 months a year, it's 12. The interest rate is 5.6. It doesn't say he's starting off with anything, so PV is equal to 0. PMT, he's depositing 200 per month, so it's negative 200. FV is what we're solving for. PY and CY are both compounded monthly and paying monthly 12. Got the calculator out. So I'm going to do this all completely live. I'll answer the questions, no pre-prepared solutions or anything like that. I'm doing it just like you would. 5.6, 0, PMT negative 200, 12 and 12. FV comes to 2462.57 to 2 decimal points. Therefore, $2462.57 in account after 1 year. Therefore, approximately equal to 2,400. Question 1A down. Calculate how long in years. So I'm finding N this time. It would take Roberto to reach his savings goal of 10 grand. Assume that the monthly deposit and the conditions of the account remain constant. I 5.6. PV, start off with nothing. PMT. So I'm going to use my my payments here from previously because it says the conditions remain constant. So negative 200. FV is equal to, he reaches his savings goal of 10 grand. So 10,000, positive 10,000. PY and CY are both 12. So FV 10 grand. Alpha solve. 45.04 to 2 decimal points. That's just my cat's going crazy. And I like to play around during the day. 45.04. How long in years? I need to keep that in mind. 45.04 months. 45.04 divided by 12 months in a year. Is 3.75 to 2 DP years. So therefore, well, yeah, that's in 3.75 years. Just to be safe, 3 years, 0.75 times 12, 3 years and 9 months, just to cover my back. Alright, so that's question 1, A and B done. Question 1C, calculate the time in months that Roberto could save if he deposits 250 per month instead of 200. The time that could be saved, so That's tricky. That's tricky because it's referring back to the previous question. So you're not just going to tell me the time, you're going to tell me the time saved. So once again, I'm finding n. The interest rate is 5.6. Started off with nothing. This changes because he's depositing more, and that's why it's going to finish quicker. FV, he reaches his goal of 10 grand. PY and CY, both 12. Apps, finance, negative 250, reaches his goal. 36.76 to 2DP. Months, therefore 36.76 months, but time saved. So the previous question, it was 45.04 minus 36.76. 8.28. Calculate the time in months saved. So therefore 8.28 months saved, and that was from previously to 2 decimal points. State one strategy other than making larger monthly deposit. So what else can he do other than paying? He could refinance to a higher rate account. He could drop in a lump sum. I probably wouldn't go with that because that's technically just paying more anyway. The only other one I could think of is pay more often as well. So I believe that's question 1 done. I've got a printed version of the exam next to me, just if I need to do working out on paper. Yeah, that's question 1 done. Okay, question 2. Marshmallow company weighed 1,800 marshmallows. They're normally distributed, so normal distribution question, mean of 13, standard deviation of 0.75. Complete the scale on the normal distribution graph. Below the mean was 13, so it's going to be 13.75. 0.75, so 75 times by 2 is 15, so it's going to be 14.5 and 15.25, back the other way, 12.25, 11.5, 10.75. That's the scale done. Calculate the percentage of marshmallows. So it's asking for the percentage, it's not giving it, so it's a normal CDF question. So when you're working these out, you should always show how you worked it out. You would expect to weigh more than 14.5. So the lowest I'm interested in is 14.5. That's going to be the lower. The upper is going to be E99. The mean is 13. The standard deviation is 0.75. Second, vase. Second on the list. Normal CDF. 14.5, E99, 13, 0.75. That gives me 0.0228 to 4 decimal points. Calculate the percentage, so times that by 100, so therefore it's going to be 2.28% are more than 14.5 grams. Don't forget your answer statements. That's B done. So this is at 0.53. I want the other one to be at 1.07. So they don't actually give you enough space to draw the graph to double the height. This isn't printed, so I don't know how tall it is, but as long as you grab your ruler and you make sure that the height of the next one is double the height. So it's going to be at, what was the 1.07, I believe it was. We'll do it on the calculator again. 0.4 divided by 0.375, 1.07. So 1.07, but the standard deviations are different. So 0.75, 0.37, they're exactly half. So that's one standard deviation away, 2, 3. And that's one standard deviation away. Oop. Another below, another below. So the inflection point needs to be one standard deviation away, about halfway down. Inflection point, one standard deviation away, halfway down. So I can draw the concave section. It's going to look dodgy as, but that's what happens when you're drawing with this pen on a glass screen. And then just make sure it almost finishes. About 3 standard deviations away. So there is your second normal distribution for the new marshmallow machine. Okay. C. The marshmallow company rejects all marshmallows that weigh less than 11.7 grams. So you have to be careful here because it's not asking the percentage, but it involves finding the percentage. I want to know how many of the 1800 marshmallows, but remember this is normal distribution. All I get is the percentages. So I find a percentage first and then work out the number after. So anything less than 11.77. So normal CDF. My lower limit is infinity to the negative direction, negative E99. The highest I'm interested in is 11.7. Mean of 13, standard deviation of 0.75. That gives you negative second comma 11.7 0.0415 to 4 decimal points. That's already a decimal, so that'll be 4.15% rejected, but remember I want a number, so 0.0415 times by 1800 marshmallows that were tested, 74.7. So, yeah, go to the next whole number, therefore 75 marshmallows rejected. Calculate the minimum weight of the heaviest 12% of the marshmallows. So it's giving you a percentage, so this is going to be an inverse normal question. So inv norm. What do I put equals there? Inv norm bracket. So it's the heaviest 12% of marshmallows. If you have an older calculator, it only works in the left direction. You can only put the tail in the left direction. So the heaviest 12% is up there. So if you've got an older calculator, you're going to be finding inverse normal of the bottom 88%. Now if you've got a newer calculator, you can set the tail to the right, that's fine. But this is an older calculator, so 0.88, comma 13, comma 0.75, comma, and I'll just, for the people with a newer calculator, you would be writing to the left there. So unfortunately, I don't have a newer calculator, I have an old one. So the tail is always to the left for the older ones. So it gives you 13.88 to 2 decimal points. Therefore, 13.88 grams is the lightest weight for the heaviest 12% of marshmallows. The Marshmallow Company buys a new production machine. The new machine produces marshmallows with weights that are still normally distributed with the same mean weight of 13 grams, but it's got a tighter standard deviation. On the graph in part A, draw the distribution curve for the weights of the marshmallows that will be produced. So I'm going to draw two normal distribution curves on the same scale, so I need to determine what their heights are. So the height of the first one, because that's already drawn for us, will give us the scale. It's 0.4 divided by the standard deviation, which is 0.75. 0.4 divided by 0.75, 0.53 to 2 decimal places. The new height is 0.4 divided by 0.375. .07. So yeah, it's double the height, essentially. And that helps us with the scale pretty nicely. So go back to the next page. 0.531. F, explain why using the new production machine results in fewer marshmallows being rejected. Well, you can see the reason for that is because it's got a smaller standard deviation. So, new machine has smaller ST-dev. Thus, you're not serious when you say thus, it is less spread out around the mean, so less marshmallows fall below the, what was the limit? 11.7 gram level. So less are rejected. That looks like a G. Let's fix that. Less are rejected. You could possibly answer that with normal CDF as well. I'll probably do that too, actually. Yeah, I'll do that to cover my butt. So normal, because you already have the how many are rejected for the old machine here. It's 4.15%. Normal CDF. Do the same working out. The only difference is the standard deviation. That spits out 0.026 4 to 4 decimal points. So you can see there's less rejected compared to before. So therefore 2.64% rejected compared to 4.15% before. Just to comprehensively answer that question, probably don't need to do that. The sentence that I've written there is fine. So that is the next question done. All right, question 3. A company has 4 employees: Adrian, Ellen, Kathy, and Ishraq. Love those international names. Who can perform any one of 4 tasks to build a cabinet. The company wants to determine which employee should complete each task to minimize. So always highlight what you're actually trying to do. You're trying to minimize. So you're applying the Hungarian algorithm as normal. The table below shows the time. Interpret the meaning of the value 40 in the table below. 40 lines up with Ishraq and task 1, so takes Ishraq 40 mins to complete task 1. I was going to say that's a bit of a dog move because it's the slowest, but no, someone's slower as well. Ellen's slower at task 4. So now state which employee takes the longest to complete task 4. Oh, okay. The exam itself is throwing shade at Ellen. So Ellen is the longest to complete task 4. How do I work that out? Well, task 4 is the column. She's the biggest number in the column. Use the Hungarian algorithm to determine which employee should complete each task to minimize the completion. So I'm running the Hungarian algorithm. I've already got the matrix drawn up for me, so I might as well use it instead of taking up the grid working out space. 21's the smallest. 21's the smallest. 20's the smallest. 26 is the smallest. So you're taking 21, take 21, take 20, take 26. So now I'll use my working out space provided. (26) take 21. 5, 0, 1, 4, 10, 7, 0, 21. 29 take 29. 6, 0, 7, 26, 30, 40, 14, 0, 2, 9. That's the rows done. Smallest number is 5, 0, 0, 4. So minusing 5, minus 0, minus 0, minus 4. So going to the right, 5 take 5 is 0. 10 take 5 is 5, 4, 9. Nothing to this column. Nothing to this column. 0, 17, I think. Yep. 17, 4, 3, 5. Can't believe the hardest thing about this is adding and subtracting. Okay, cover the zeros. The most I can hit in one line is 3. The next most I can hit is 2. The next most I can hit is also 2 at the same time. So 3 lines, 4 rows. Not enough. So what's the smallest uncovered number? It's 3. New matrix. Nothing happens to the single covered. Add to the double covered. Add to the double covered. Nothing. Take from the uncovered. Nothing. Nothing. Take nothing, nothing, take, nothing, nothing, take. Cover lines again. The most I can hit is 3. The most I can hit is 2. The most I can hit is 2 again. And the most I can hit is 2. Wait, something funny happened there. And I shouldn't have taken. Oh, I have to go back. I told you. You're getting warts and all here. Nothing, add, nothing, take. Nothing, nothing, take, nothing, nothing, take, nothing, nothing. I shouldn't have done anything to 2. Take the 2. That's better, I think. I'm not fudging this. You're going to see it all. So cover. Most I can cover is 2. Next most I can cover is 2. 1, 2, 2. And then this last 0, I'm just going to cover it up horizontally. It doesn't matter if you do it vertically or horizontally. So now finding the pattern of zeros. There was 4 lines I drew. So what's the pattern of 0? A line in its row. No. A line in its column. Yes. A line in its row. A line in its column. No, leave it. A line in its row. Yes. A line in its row. A line in its column. No. A line in its row. A line in its column. No. A line in its row. And a line in its column. Yes. So the last is decided through process of elimination. Using the Hungarian algorithm to determine which employee. So we've just done that. We just need to give the assignments. So, Adrian. I like writing them out first. Ellen, Kathy, and Ishraq. Adrian does task 1. Draw my arrows in. Ellen does task 3. Kathy does task 4. Ishraq does task 2. Okay, so C1 done. C2, find the minimum completion time for building a cabinet. Alright, well that's useful. I have to flip between pages. I better write that stuff down on my written exam. 26, 26, 21, 27. Okay, now I can go back. So 26 plus 26 plus 21 plus 27. Lucky you're doing the exam with a calculator. That's exactly 100 minutes. If Kathy was unable to complete task 4, state the effect this would have on the minimum completion time for building a cabinet. Well, Kathy was doing task 4. This would increase the completion time. Why? Because the Hungarian algorithm said that she was assigned to it for the shortest completion time. Why did I underline the completion time? This would increase the completion time. She was assigned to task 4 for the minimum. So if she can't do task 4, the only result is going to be that it's going to take longer. Alright, Adrian injured his hand. He now takes 10 minutes longer to complete task 1 and 10 minutes longer to complete task 3. Use the Hungarian algorithm, the new reduced array is. So I'm the kind of person that would want to check that they did this right, but you don't have time in your exam, so just take it that they've done it correctly. So you have to assume that they did the rows and columns and properly. Under the new condition state, which employee should complete each task to minimize the completion time? So essentially you're just covering up zeros to start off with. So the most I can hit is 2, 2, 2 and 2. That took 4 lines. So there's going to be a pattern now of zeros. A line in its row, no. A line in its column, no. A line in its row, no. A line in its column, yes. A line in its row, yes. A line in its row, no. A line in its column, yes. A line in its row, a line in its column, no. A line in its row, yes. Under the new conditions, state which employee should complete each task to minimize the completion time for building a cabinet. So write them out again. Kathy, arrows. Adrian is the top line. He should be doing task. Ellen, task 3. Kathy, task 1. Ishraq, task 2. Show that the new minimum completion time for building a cabinet will be 101 minutes. Alright, I can't, it's going to be hard to flip that page. I just look at my printed exam. So, first column, third row is 29. 29. Second column, bottom row is 26. Third column, second row is 21. Fourth column, top row is 25. What does that add up to? 29 plus 26 plus 21 plus 25. 101 minutes. Explain why the minimum completion time for building a cabinet has not increased by the 10 extra minutes it takes Adrian. Because Adrian is not doing task 1 or 3. The assignment's gone around and assigned it to other people, so it doesn't have the full effect of Adrian's injury. He's not doing either of those tasks. So I think that is, usually they're 2 pages. I think that's question 3 done. Let's have a look. Yeah, question 4. Julianne has obtained a $280,000 home loan. The interest rate is 4.5%. It's going for 30 years and it's compounding fortnightly. He's doing fortnightly repayments, so PY and CY decided for us. N is going to be 30 times 12, which is going to be... No, it's not going to be 12, it's going to be fortnightly. 26. 30 times 26, 780. I is going to be 4.5 PV. It is a loan, so she gets given 280 grand. PMT, we're finding the payments. I want to owe nothing at the end of the loan. PY and CY, but not 12. I keep writing 12. 26. Apps, Finance, TVM, Solver, 780, 4.5, 280 grand. 0, 26 for both. Alpha solve. Negative 654.48 to 2 decimal points. Therefore, $654.48 per fortnight. show that the balance of Julianne's loan after 5 years is approximately $255,000. The balance you're finding FV after 5 years. So N is going to be 5 times by 26. 130. I is equal to 4.5. PV is what they started off with, making those payments we worked out last time. FV is what we're solving for. PY and CY are both 26. So now this is something to be careful with. You need to make sure you actually change your PMT to 654.48, because that's what I'm indicating here is in my TVM solver. If you left the 654.48 from your previous working out, you're going to get a different answer. So FV is going to be negative 255,259.94 to 2 decimal points. Therefore, 255,259.94 balance after 5 years, approximately equal to 255 grand. Next question, C. Calculate the difference between the interest paid over the first 5 years of Julianne's loan and the amount of interest paid over the last 5 years of her loan. Okay, this is a tricky one. It's an interest question. So, interest of the 5 years. It's 130 payments of $654.48 minus, and we need to work out how much was actually paid off of the loan. It went from 280 grand to 255,259.94. 30 times 654.48 minus 280,000 minus 255,259.94. $62.34 interest in the first 5 years. We don't have the elements. We haven't worked out what was paid in the last 5 years, so I need to do the maths for that. So what we would do is work out what the balance is in the last 5 years. So N is going to be 25 times by 26. So go to TVM solver, 25 times 26 is 650. Everything else remains the same, but we're solving for FV. So I, PV, PMT, PY and CY all the same. Solve for FV, and it tells me that there's $76,133.03 balance after 25 years. So that's what you've got to pay off in the last 5 years. So that gives us the info we need to find the interest of the last 5 years. So the interest of the last 5 is still going to be 130 payments of $654.48. But that is paying off the remaining $76,133.03 of the loan. And I'm getting the loan down to $0 owing. So 130 times by $654.48 minus 76133.03. It gives me $8,949.37. Trying to find the difference between. So 60342.34 minus $8949.37. 342.34 minus 8949.37. $51,392.97. Um, 60342.34 8949.37. Yeah, 51392.97 difference in interest paid between first 5 years and last 5 years. And I can already think of what question they're going to ask next. He's probably going to ask why there's a difference. Yeah, and that's true. Explain why there's a difference between the amount of interest paid over the first 5 years, the amount of interest paid over the last 5 years. It's compound interest. The interest is calculated on a compounding basis as a set percent of the remaining balance. In the first 5 years, it's a larger balance, so more interest. In the last 5 years, there is a smaller balance. Or small balance. Less interest charged. That's 2 pages down, so that should be question 4. Yeah, question 5. So we've got our first networking question. Engineering companies design super fast battery charger. Needs to go through processes, time needed to complete. It's giving you a network. Most of my questions in my test have asked you to draw these from scratch. List all the processes need to be undertaken before N can start. So N is here. One of the prerequisites requires J, G, H, so it needs all of this. So it needs A, B, C, D, E. Doesn't need F, G. It needs H, and it needs J as direct prerequisites. Using the network diagram, find the critical path and the minimum completion time by completing a forward and backward scan. Write the critical path. Forward and backward scan. 0, 8, 12, 10, 14, 12, 19 is bigger. There's 3 different ways to get to this one. Could be 19 plus 11, which is 30. 12 plus 2, 14. Yeah, 30. 30 definitely. 10 plus 8, 18, 30 plus 6, 36, 19 plus 7, that's going to be 26, 26 plus 12, that's going to be 38, 34, 38, 39, 40, 41, 30 plus, make sure that's 30 so it doesn't stuff me up later, 41. 41 plus 8, 49 obviously, and only one way, 59. Backward scan, 59, 49, 49 to 41. It's good to always look for the critical path first. 41 take 3, that's going to be 38 there. 49 take 2 is going to be 47. 41 take 8, ooh, it's going to be 33. 41 take 6, 35. 38 take 4. 38 take 12 is going to be 26 here, 26. We'll have to do this path, 34. 26 take 7 is 19. 34 take 11. 23 along here. Sorry. 34 take 2, 32. 34 take 5. 29 goes there. 19 take 7, 12. 19 take 6. 13. 13 take 8. 5. There's going to have to be a 0 on here somewhere. 12 take 12, 0. Yes. 29 take 10, 19. Anything else that I've missed? One take 3. That's about right. What is the critical path? The critical path is I'll do this in green. Highlight. C, E, F, M, Q, R, S. C, E, F, M, Q, R, S. Minimum completion time is going to be 59 minutes. That's what it says in the node. Calculate the amount of slack time for process P. Where's P? Oh, there it is. P is along there. 38 to 47. So 47 minus 38. 9 minutes. Slack for P. Not B, P. P. Is that page done? The engineer in charge has recognized the battery charger. No, not recognized, has redesigned the battery charger slightly. And as a result, the time to complete N has now increased from 4 to 10. Mark the new critical path. We're just going to have to do another forward and backward scan. 0. 8, 12, 10, 19. Very similar at the start. What's different? 19, 26, 36, 7, 38. Well, that's the only way. 26, 38, 30 plus, that's 40 is going to be 43, 43 or 36, 43. 43 plus 8, 51. 51 plus 10, 61. Why would you want to do this to the battery charger? It's slower. Whatever. 51. 51 take 2 is going to be 49, because the critical path is going to be through here. 43. 43 take 3, 40. 40 take 12, 20, so it looks different up the top there. 40 take 10 is 30. 43 take 6, 37. 28 take 7, that's 21. 30 take 11 is 19. 30 take 5. 43 take 8. Ooh, okay, 35. This is going to be 25. 25 take 10 is 15. 30 take 2, 28. 19 take 7, so that's the critical. 19 take 6. 13. 13 take 8. 5. 12 take 12, 0. Anything I'm missing there? I don't think so. Mark the new critical path on the network above. C, E, J, N, Q, R, S. Calculate the difference between the original completion time and the new minimum completion time. Well, now it's 61. It used to be 59, therefore 2-minute difference. The engineer can change either process J or process H to make either process 3 minutes faster. State which process the engineer should change. J or H. H is not on the critical path. H has a slack time of, it's not going to affect it. J should change J to be faster because it is on the critical path. So a reduction in time would make the minimum completion time faster. As long as you affect the critical path, it's going to affect the project. And that's that question done. Alright, statistics question. Scatter plot below. Shows winning times in minutes. So what that's telling me is that as time progresses, it takes less and less time to complete the marathon. State the dependent variable, the scenario. It's the winning time. In minutes, interpret the meaning of negative 0.527 in the linear equation for this. Well, what that's telling me is got a negative slope for every year, or every 10 years it looks like, it's along the bottom, for each year, but the slope is for every 1 unit of the independent variable. So for every year since 1900. The winning time of the marathon, because it's negative, it decreases by 0.527 minutes. Stage. The data in the scatter plot has a coefficient of determination value of 0.812. Determine the value of r. Well, if r squared is equal to 0.812, r is going to be the square root of 0.812. I'm going to break that. 0.9011 to 4 decimal points. It's not that simple because remember r has a direction, and it was obviously a negative correlation, so it's going to be negative 0.9011. So be careful, take care. Correlation is in negative direction. Using a linear model, predict the winning time to the nearest minute for the men's marathon in the year 2040. So winning time for the year 2040 is going to be 1173, take 0.527 times 2040, 1173, negative 0.527 times 2040, negative 1075.08 is equal to 97.9. I'll just double check that. 1173. I don't trust my mental arithmetic. Yeah, 97.92 minutes. Comment on the reliability of calculations in part D1. Well, the data, if I look back on the printed, the data doesn't go up to 2040. It stops before 1980. This is definitely not reliable. R squared is 0.812, so the correlation is not very strong to begin with. And the data does not go beyond 1980, so this is an extreme extrapolation. So we don't know if the relationship continues as it appears to beyond 1980. Alright, extrapolation bad. A residual plot for linear model is shown below. Circle 2 points in the residual plot that represent years in which the winning times were much longer than the model predicts. So remember, the line of best fit is that. This is predicting what the dots should be at So anything below that means that the winning times were lower than expected. Anything above that is higher than expected. It's looking for much longer. These are the two much longerest, or whatever the correct terminology is for that. If the two data points for these longer winning times were removed from the scatter plot on page 12, it will result in a new linear model. Tick the appropriate box to indicate which one of the following values is most likely to be the slope of the new line of best fit. It can't be negative 0.527 because it would definitely change it. Remove from the scatter plot. Just double check that scatter plot from the top two ones. If they were removed, the line would not point up so far. So right now it's like this. These 2 points are pulling it upwards. They're exerting it's not a force obviously, but they're pulling the line upwards. If they were removed, the line would get a bit flatter, so less steep. So right now it's negative 0.527. The least steep would be negative 0.455. That's the way you can sort of work it out in your head visually if you wanted to. Alright. You may write on this paper. No, I would not like to write on this paper because I don't need it. Looks like the next question is a network one again. Use the information in the table above. State one job is on a critical path. Justify your answer. Well, anything that has no slack time is going to be in the critical path, so it could be any of A, could be E, could be F, could be any of these with matching. So any of A, E, F, H, J are on the critical path as they have no slack time. EST matches their LST. Calculate the minimum completion time for the construction of the road. So you've identified what's on the critical path. It's A, which is 10, E, which has a duration of 4, F also has a duration of 4, H has a duration of 5, J has a duration of 3, 14, 18, 23, 26, and it's months, time in months. 10, 4, 4, 5, 3, 26. Done that. Explain why there would be no advantage in reducing the time taken to complete job G. Use the information in the precedence table on page 16 to support your answer. Well, firstly, I can just remember off the top of my head, G is not on the critical path, so has no effect on the minimum completion time. What else can I say? It's got a slack time as well because it's not on the crit path, so G has slack time of 4 months. So making it faster would just increase the slack time. that does that. The completion of job C is delayed. How many months leeway does the council have in order for the delay to have no effect? C has a slack time of, let's look at the table, 6 to 7. C has slack of 1 month. So has 1 month. Leeway, delay of 2 months or more. Changes, critical path. Draw a labeled network diagram using the info in the precedence table on page 16. So to stop you from having some form of like seizure, I'm not going to flip back and forth between pages on the screen. I'm just going to use my printout of the exam so I can look at the table, and I'll go through the process of drawing up the network using that. So I have 2 things that have no prerequisites. So my start from the left. Start node. A and B both come out of the start. C comes out of B. D comes out of A and C. So I'm going to erase this. D comes out of A and C. E comes out of A and C. F requires E. G requires E. H requires D and F. I requires D and F. J requires G and H. So that's not good because they would have to cross over, so I'm going to where am I going to go? Down or up? Is I a prerequisite? I is not a prerequisite. So I'm going to go J up here. J is not a prerequisite. I is not a prerequisite. So the end node is going to be there. So just double check. J requires G and H. I requires D and F. H requires D and F. G requires E. F requires E. E requires A and C. D requires A and C. C requires B. A and B require nothing. So draw a label network diagram. That's what we've done. You don't need to do a scan of it. You've already done all the critical path stuff, so that's a label network diagram all done, except for the fact that we need to put the durations in, otherwise you'll probably lose marks. So A is 10, B is 6, C is 3, D is 7, E is 4, F is 4, G is 5, H is 5, I is 7, J is 3. Right, next page. Another statistics question. A car was bought for 44 grand and the value of the car at the end of each year of ownership is shown below. I have to get the equation. So, stat, edit. First time I've had to use this. Stat, 1, edit, clear my column. So go up to the label, L1, L2, L3, press clear on L1. It asks you what to put in there. Press enter to clear it all. So independent variable, time in years in L1, 0. 1, 2, 3, 4, 5, 6, 7, 8. 44 grand. 32,200. 24,800. 17,800. 14,200. 9,800. 7,800. 5,900. 4,500. Turn the equation, stat, calc. It says the exponential model. So I'm not doing a lin reg, I'm scrolling down to 0, exp reg, list 1, list 2. Where A and B are the constants in the form Vt is equal to 43178.21 times by 0.75 to the power of t, and I rounded all of that to 2 decimal points. Right, next, I better write that down actually, because I'm probably going to use it on the next page. $178.21 times 0.75 power of that. Next page. Calculate value after 9 years. V9 3178.21 times by 0.75 to the power of 9. So remember BEDMAS, 0.75 to the power of 9 times by 43178.21. 3242.02 to 2 decimal points. Just double check. Therefore, $32.42.02 for a 9-year-old, I believe it's age. Your old car. Interpret your answer to be. No. I have to answer the same thing again. The value of the car after 9 years is predicted to be $3242.02. It's 2 decimal points. I already rounded before. Using the exponential model that you determine, calculate the average annual percentage decrease in the value of the car. B was 0.75 to 2 decimal points. This is 0.75 multiplier. So 75% each year. So 25% decrease in value of car annually, every year. Calculate how long the car has been owned when its value is 5% of the original value. So I need to work out what 5% is. 0.05 times by the original value is 44,000. 2,200. So now you need to use the graph drawing function because we don't do hard enough maths to solve this algebraically. So y1 is going to be, well, the equation you're graphing is this: 2,200 is equal to 43,178.21 times by 0.75 to the power of x. So y1 is going to be 2,200, not 22,000, 2,200. y2 is going to be 43,178.21 times by 0.75 to the power of x. So on your calculator, y equals, y1 is going to be 2,200. It's going to be a straight line at y is equal to 2,200. 43,178.21 times by 0.75 to the power of x. Do that again. 78.21 times by 0.75 to the power of... What's wrong with my calculator? 43,178.21 times by 0.75 to the power of x. I'm going to set the zoom to zoom standard, so press zoom button, scroll down to 6 zoom standard, so that my calculator will draw it, but it won't be zoomed in properly. Now see if I can get lucky. Press zoom again, scroll down to 0, zoom fit, and see if the calculator can work out a good zoom to see where they cross over. Now it's drawn the two lines. It looks like they cross over on the screen. So I'm going to press second trace, scroll down to 5 intersect. First curve is y is equal to 2,200. Second curve is y is equal to 43,178, etc. Guess. It doesn't find it. So I'm going to press zoom again, scroll down to 3, zoom out. I'm going to zoom out once. So it didn't find it because because it couldn't find the intersection on the screen. So I've zoomed out one time. It's definitely on the screen now, so I'm going to press zoom trace again. Scroll down to 5 intersect. First curve, second curve. Guess, enter. Intersection. Interact with the... Intersect at 10.35 and 2,200. Let's round it to 2 decimal points. Therefore, 10.35 years to reach 5% of original value. It's D done. Question 9. So usually that's the last question. I don't even know how long this has gone for. Probably a bad decision to try to do all the exams in one sitting, but that's what we're going to do. Should the employer's quarterly contribution to Min's superannuation account is approximately $1,100, well, 9.5%, 0.095 times by 46 grand. That's 4,370 per annum. But it's quarterly, so 4,370 divided by 4, $1,092.50, therefore approx $1,100. Min Super account pays an interest rate of 7.6% per annum, compounded quarterly. Show that Min will have when he retires at age 65. He's currently 25, so in 40 years. So N is going to be 4 quarters in a year times by 40 years. 160. It pays 7.6% per annum. PV, it doesn't say starting off with anything, so nothing. PMT, I'm using the one I worked out, -10 at $92.50. FV is what we're trying to work out, PY and CY. 4. Apps, Finance, TVM. 160, 7.6, nothing, -10, 92.5. 4 to both. Alpha solve 1110754.02 to 2 decimal points. Therefore, has $1110754.02 in account at age 65, which is approximately equal to 1,100,000. It's a bit more than that. State one assumption made in calculating your answer to be 1. Well, you assume he maintains. Is it a he? Min? I don't even know. He, she maintains. I should know, I'm Asian. You assume he or she maintains the contributions of about $1,100 for 40 years. Hopefully you don't stay on the same income for 40 years in the job. You also assume the interest. I'm just doing an extra one for your benefit. It's only 1 mark, so you only need 1 answer. You assume the interest rate is fixed for 40 years too. Right, next page. We're almost done. When Min retires at age 65, he's going to transfer that 1,100,000 into a pension with a rate of 5.5% per annum, compounding monthly. How much is he going to withdraw monthly if he wants his pension to last 20 years? Sounds like he wants to live it up for the last 20 years of his life. So, alright, apps, finance, 20 years times by, he's doing it monthly now, so it's going to be 240. The rate is 5.5. PV. Now you got a couple of options here. You could use that amount that you worked out. FV would be from his contributions after, but this particular question is saying he rolls his $1.1 million, so I'm going to use that $1.1 million. So PV is going to be negative 1100000 because it's in the bank. We're trying to work out what he can withdraw for 20 years every month. He's going to have nothing in there at the end of that. PY and CY are both 12. 5.5. Negative 1100000. Nothing. 12. PMT alpha solve 7566.76. So that seems like quite a lot. Therefore, can withdraw $7,566.76 monthly to last 20 years. Min currently lives on $2,500 a month. If inflation averages, will he be able to maintain his standard of living? No. Inflation formula indexed for inflation is equal to the original, which was $2,500 a month, times by 1, plus the rate is a decimal, so 0.032 to the power of the number of years. He's currently living 2,500 and he's retiring. He's currently 25, he's retiring 65, so it's 40 years of inflation. So bed mass, you need to do the brackets first, then the exponents. 1 plus 0.032 to the power of 40, times that answer by 2,500. It comes to 8813.08 to 2 decimal points. Therefore, he cannot maintain his standard of living as considering inflation, it would cost him, not his, him $8813.08 per month when he can only withdraw $7,566.76 per month. So you can't maintain it based on the information or the working out that we did just previously. If Min decides to withdraw 8,500, how many years? So we're working out N. Solving for N. Interest rate is 5.5. He put in $1.1 million. He's withdrawing 8,500. He wants nothing at the end. He's doing it on a monthly basis. Apps, finance, TVM, negative, no, not negative 8,500, it's positive 8,500 because he's getting that from the bank. 196.66 to 2 decimal points. It says how many years? 196.66 divided by 12. 16.39 to 2 decimal points. Therefore, how many years will it last? 16.39 years. If withdrawing 8,500 per month. Is there anything else? That's page 21. 22, yeah, there's something else. At age 30, after working for 5 years, the interest rate in his super account changes to 7.3%. Min begins to make a voluntary contribution. By himself of $300 per quarter. How much money is going to be in the account when he retires at age 65? So this is tricky because there's the 5 years that it's not asking you to work out, so you need to be vigilant about that. So first 5 years, you need to do that separately because the interest rate changes. Whenever there is a change in the conditions of a loan or an investment, you need to split up the TVM solver for it. So N is going to be 5 years, paying quarterly. Apps Finance TVM solver, 5 times 4, 20. It's was 7.6. He started off with nothing. He was putting in $1092.50, and he was doing it every quarter. Alpha solve 20, I is 7.6, PV is nothing. He was putting in negative $1092.50. Solve for FV, PY and CY were both 4. So I get 26282 and 15 to 2 decimal points. Therefore, $26282.15 in account after 5 years, and then the interest rate changes. $30 to $60, so it's going to be 30. No, not 30. 65 take 30 is 35. 35 times 4 is 140. So remaining years, n is going to be 35 times 4, which is 140 quarters. The rate went, it didn't go up, it went down. 7.3. PV, he started it off with $26282.15 in the account. He's paying an extra $300, so it's going to be negative $1392.50. FV is what we want to see what he ends up with. PY and CY are both 4. 7.3. Negative 26282.15. Negative 1392.5. Alpha solve 121401.05 to 2 decimal points. So therefore, min will have $1214015.05 available in her super account. It's 2020, we can't assume. Account when he retires. She retires at 65. One, two, one. Just double check. Yep. Okay, so that is the last page. I'm not sure how long that took. We'll be able to check when I make the video. So that's the solutions video for the 2017. Let me just check the printed. The 2017 sample general mathematics exam. Hopefully that helps you out, and I'll see you in the next video. No, blank.